We can also use completing the square to change from standard form of a quadratic equation into vertex form of a quadratic equation. So if you recall from chapter 3, vertex form is that y is equal to a times x minus h squared plus k. And remember that h comma k is the vertex. There is a negative sign in that equation. So we can use completing the square to convert standard form into vertex form. All right, so let's take a look at number 9. I have a quadratic equation here. Notice that y is not indicated as 0 this time. I'm not solving. I am using this form of the equation and transforming it into the vertex form. So I want to leave the y alone. I'm not going to replace it with a 0. But I'm still going to use the same technique I've used before. I want to take this c value and move it to the other side of the equation so that I can put the c value that makes a perfect square trinomial here instead. Now, on the other side, I don't have a number, I have y, but that's okay. So I can say y minus 18 and then plus the number that I'm going to come up with in a minute is equal to x squared minus 12x plus the number that I'm going to calculate for my new c value. Let's calculate the new c value. C is equal to negative 12 over 2 squared, which is negative 6 squared, or a positive 36. So that's the number I'm going to plug in here, 36, and I'm going to continue simplifying. On the left-hand side, I can combine the negative 18 and the 36, and I'm left with y plus 18. And then on this side, I know that I have my perfect square trinomial now that I've set up by completing the square, so I can rewrite this as x minus 6 squared. All right, we are getting really close to having vertex form. The only thing that I need to do is get y by itself and move the constant over here to the other side. So now that I am at the end, I'm going to subtract 18 from both sides, leaving me with y is equal to x minus 6 squared minus 18. And this is my vertex form. The last thing I want to do for this problem is just go ahead and identify what the vertex is, because it's really easy to read from the vertex form of the equation. Remember that it is h comma k. So my vertex, my h value is 6, not negative 6. Remember, the negative is actually in the equation. So it's 6 and negative 18. Why don't you try number 10 and then come back here and see if you got the same solution that I did. Okay, let's talk through this one real quick. I know that I want to start by moving my current c value to the other side. So I can move 4 to the left by subtracting 4 from both sides. So now on the left-hand side, I'm going to have y minus 4, and I've left space to put my new c value. On the right-hand side, I've also left space to put my new c value, which I calculated to be 9. So 9 goes in the blanks, and then I can do this little bit of adding. Negative 4 plus 9 will give me 5, and I can factor this perfect square trinomial to be x plus 3 squared. Finally, in order to get this in vertex form, I need to get y on the left by itself, so I'm going to subtract 5 from both sides, leaving me with y is equal to x plus 3 squared minus 5. Finally, identify the vertex. If I see a positive 3 here, then I know that the x value of my vertex is a negative 3, because remember, there was a negative sign built into the equation up here. The vertex is at negative 3, negative 5.